Alright, y'all. First and foremost, thank y'all for coming. Really appreciate it. I hope you enjoy this. So, I'm going to be talking about React V3. I'm going to mix in some TypeScript concepts. Not going to focus too much on TypeScript. The kind of core crux of this talk is going to be kind of really showing everyone like how and what responsibilities we can turn over from V3 to React. In other words, like a lot of people are building their front-end applications in React, but then you want some sort of a dashboard utility, or you might find some use for a piece of data visualization that you need. And a lot of the problems that people are having, I think, in the past 5 years or so, is like how do we kind of lend those responsibilities. So with D3 V4, which came out a couple years ago, they broke up the library. It was like one monolith library. They broke it up into submodules for ESM, which kind of works really well with React, because now you can kind of only take the parts of D3 that you need. So I'm going to touch on what parts of D3 that we can probably borrow, and what parts we can hopefully count on leaving out. So I'm going to cover kind of like an overview of the D3 module system. I don't have slides for that, so I'm just going to kind of dive into the internet and show you what I'm talking about. I'm going to cover React reconciliation, which is namely React's responsibility for updating the DOM, and why we might want that over D3's DOM manipulation methods. I'm going to cover some React lifecycle methods. The goal here with this talk is to really, I want to stress, because I've been through this before and it's rough. When you're developing a React component, a lot of times we tend to move a lot of our logic into component did mount, which causes this initial render that is kind of a waste. And when you're working with like a data visualization, every render counts. So we're going to try, the goal here is to render our data visualization on the first render.
All of it? Just
the whole shebang. So there's a difference between JSON and hierarchical JSON. I'm going to talk a little bit about that once we dive into the code. And finally, I'm going to touch on, again, how to replace D3's update pattern with reconciliation. We're going to eagerly render up visualization, like I said. And I'm going to kind of briefly touch on typecasting engineers. Okay, so this is like kind of a broad array of topics that we're blending together, and it's kind of assuming a lot of knowledge. I kind of want to be clear with what I'm not covering. I'm not covering React basics. This isn't like a hello world React application. I'm not going to cover D3's enter update exit pattern, because that's kind of what we're trying to get rid of or eschew. I'm not going to cover usage and configuration of TypeScript, because that could take up its own hour, maybe 2 hours, 3 hours, 4 hours. And I'm definitely not going to talk about Webpack build optimization, although I'm going to kind of nod to that in a sense by suggesting that if you do end up developing React in D3, to go the route of importing each D3 module that you need as it's a standalone module, and that'll kind of optimize your Webpack build inherently. And the Svg coordinate system, I mean, Svg is like a world of its own, and I definitely don't have time to cover how that works and how Svg works. I'm just going to touch on kind of what's necessary to get through this presentation. Sorry, I haven't been updating these slides at all. So what we will cover, what we will not cover, I went over these. Okay, so I took this straight from D3.js homepage, right? In their own words, or rather in the words of Mike Bostock, D3 is a JavaScript library for manipulating documents based on data. D3 helps you bring data to life using HTML, SVG, and CSS. So when he's talking about manipulating documents, he's talking about like the whole document object model. So that's all the HTML, SVG, and CSS. Now I think it's interesting because like SVG is part of the DOM, but it's listed here. I mean, he makes it a point just to specify HTML, SVG, CSS. So I think this kind of dives into the talk and this talk about what do we want React to be responsible for? What do we want D3 to be responsible for? We want React to be responsible for the DOM, and eventually, we're going to want D3 to be responsible for SVGs because that's what D3 does best. D3's emphasis on web standards gives you the full capabilities of modern browsers without tying you to a proprietary framework. Now, I highlighted this part because, like, what do you think they're talking about right here? Like, when they say proprietary framework. They're talking about, like, Angular, right? Maybe React's on a framework, but you get the point. So kind of the goal with this D3 library was to kind of create something where you could literally just have an HTML document, drop a script tag in there, and write a whole entire long React script. And even with D3 V5, the newest one, there's actually a submodule now called D3 Fetch, which allows you to fetch data. So they're literally they're pulling in all the different elements of what a data-driven document is. I mean, first, for a data-driven document, you need data. Where do you get that data? I mean, you could create a JSON file and import it and drop it in, but in reality, you're probably making some sort of a request. So that request now is built into the D3 library. Do we need that if we're developing in React and we're trying to fit D3 into React? Probably not. Probably have a whole folder full of like fetch utils or whatever that are responsible for handling those fetches. So there's things that are kind of part of the core D3 library that make it a standalone library that we definitely don't want. That's kind of the point I'm going to drive home. So I kind of changed this to my version, right? Now I'm saying D3 is a JavaScript library for manipulating Svg elements. Let's keep it simple. D3 helps you bring data to life using Svg and CSS because we can use CSS properties on Svg elements, which is useful, especially if you're developing a library component and you want to color things and you want the consumers of that library component to color things. CSS is probably the easiest way to go about that. D3's emphasis on web standards gives you the full capabilities of modern browsers, but if you're using React, you can pick and choose only the necessary modules. Cool.
That's a feature only with React?
What do you mean?
Like, you can't do that with Angular or like Vue?
I just put React because I'm giving a React presentation. But yeah, I mean, if you're using Angular, if you're using Vue, I'm sure you can pick and choose like the necessary modules. Yeah, that's a good question, I guess. Yeah. Okay, so I want to talk about D3 modules. We're going to look at 3 things right now. First thing I'm going to show you is a data visualization that somebody did, right? And this data visualization sums up all the D3 modules that are available on NPM. And what this person did was they essentially created a matrix or a dual axis where I think on the left is NPM downloads, and then on the bottom is GitHub stars, or it might be the other way around. But like, the illustration here is that all these are part of the core library. That's why they have the most downloads. Mind you, like each one of these faces is an individual D3 module, right? So D3 is broken up into a ton of modules, as you can see. There's all these modules that encompass it. So at the top, the most common ones right here, this is D3 shape, which is used to create Svg elements, which, I mean, like I said, Svg is its own world, so a submodule like this is very useful. There's D3Q. All those are clickable, apparently. See, all these are developed by Mike Bostock. That's why like these are all blue, and he's the author of D3. But then you have some other ones over here, like this one. This is developed by somebody named Susie Liu. This is called D3 SVG Legend. So again, like, you know, I mean, this is the most common D3 submodule right here that's not developed by Mike Bostock, and it has SVG in its name. So it's like what are we really using D3 for? SVGs. I really wanted to show you this visualization because I think it's interesting that D3 is a data visualization library, and its documentation is like huge, which I'm going to show you. And there's no, I think this is interesting, there's no data visualization for the D3 docs, right? So if you don't have a book that's like how to use D3 or D3 in Action by Elijah Meeks, which is a great book, I highly recommend it. Then if you know a normal way that you familiarize yourself with something is reading the docs. If you try to read the D3 docs, you'll just hit just like a wall of just, you know, being just essentially lost in all different types of submodules. And the problem with a lot of these submodules is that they're not categorized, right? So there's a variety of different D3 submodules now, but we could kind of group these submodules into categories. And nowhere in the D3 like official documentation do they try to do that, and which is interesting because like they have like a D3 they have blocks, D3 blocks, which is a beautiful website. There's all different examples of D3 on this website right here, right? There's literally all these different visualizations. So I think it's kind of useful to create a visualization for the docs. I'm not going to endeavor to do that in this talk. That's kind of something I would like to do on the side, because I think people would get a lot of use out of that. This is, I call this the D3 hidden docs, because if you try to find this piece of documentation, it's kind of lost. And you know, somebody did this when D3 V4 came out. And I think this is like really ugly, obviously, but really useful. You know, you have data space, and then they break the data space down into things like query and generation, parsing, formatting. So you can see all these like subcategories have to do with manipulating data. D3, data-driven documents. You're going to have to manipulate data potentially if you're working with it. Now, if you're manipulating the data before you pass it into a React D3 module, you might not need some of these functions, right? Like D3 DSV. You know, you might already have the data in the format that you need. You might not need D3 DSV. But what I think is really cool about this page and why I think it's worth showing is it kind of organizes these submodules into these categories, which I think is really important to take away if you want to learn about the different submodules, right? We're going to be using this one right here, D3 hierarchy. This is probably, I don't want to say the most common. D3 is really popular for like line charts and bar charts and things like that. That's not D3 hierarchy. But D3 hierarchy is good for things that are hierarchical. So, tree diagrams, tree map diagrams, circle pack diagrams, which we're going to touch on a little bit today. All right. So we go back to sorry. Definitely a better way to do this. All right. So let's talk about SVGs, right? SVGs are beautiful, and there's a reason why people love them, right? Released in 2001, it's more powerful than other file formats, unlike raster formats, JPEG, GIF, PNG. SVG images remain crisp and clear at any resolution or size. And you see this almost every day. If you're using your iPhone, if you're using a website and you see a company's logo, like the Instagram logo or whatever, those logos are usually in SVG. Why? Because if you shrink it down, it's going to be crisp and beautiful. If you blow it up and you put it in the header of the website, of the landing page, it's going to be beautiful. So that's why people use SVG, is because it's scalable, right? The vector part has to do with X and Y coordinates. So, in other words, when you drop an SVG canvas onto the DOM, that canvas is essentially a viewport. That's literally what it's called, the viewport. And that viewport is showing you a coordinate plane, but it's only showing you the piece of the coordinate plane that is available within the viewport. Just like how if you're on a website, right, you can't, if you shrink the website down and you shrink the width down, things are going to change on the page. You might not be able to see everything. The website is going to adjust to fit everything in the viewport. Same thing with SVGs in some sense, where what's visible in the viewport can be manipulated by manipulating the viewport. So if you zoom in the viewport, you could essentially blow up whatever is on the canvas and make it bigger. So that's how you do things like zoom and pan and things like that. Is you're really just manipulating that coordinate plane that you're looking at. So you get the scalable from the vector, and obviously it's a graphic because you can see it, right? So I made this slide. This is the Debian logo. I don't know. This is like pretty big. I think you could see this. This is a very simple but deceptively incredibly difficult SVG, because the way that SVGs work is they accept elements, just like the way a DOM works. A DOM has DOM elements, right? You could have a div, you could have HTML5, you could have body, you could have header, you could have a variety of things. With SVG, it's the same thing, right? There's some shapes that come with SVG, like you could have a circle, you could have a rectangle. You could drop those raw shapes into an SVG, and SVG will know how to render it, right? Is this a circle? No, it's not square. So it's like, how do you get something like this? And that's where the Svg path comes in. So Svg has an element called the path element. The path element accepts a parameter, an attribute called D. The D is responsible for creating the path. So I'm not gonna dive into SVG right now and explain how to create this from scratch, because that's way beyond the scope of this. But this is the part that you see, and this is the part that you read, because this is what the path looks like underneath the hood, right? So you see up in the top left, you have a path element, right? And then here's your D attribute right here. And this is pointing to, like someone like might have coded this by hand, but probably not. You know what I mean? Like this is, and there are people that know how to write this from scratch. Like this M here has to do with like the pen and where you're dropping it. And then all these values here have to do with how you're moving that and how the fill is being applied. So there's a science to this. It's not gobbledygook, but this is like not what I want to do for a living. So let's move on. All right. So now, how does React tie into this? And why do we want React to tie in? Well, React is really good at manipulating the DOM because of its reconciliation algorithm, right? And the algorithm is like really simple. It just creates a linked list and creates a tree of fiber nodes, and you essentially have a parent-child relationship, and then you can have a sibling relationship. So depending on what elements need to be re-rendered, that works its way up the tree, and then all those are essentially re-rendered. So this is a really important slide right here. This is something that Dan Abramow shared when React 16 came out. This is like the most up-to-date lifecycle method diagram that's out there. So you have your constructor. We never start from the left and we go down. So we mount, and the first lifecycle method we hit is the constructor. Then you have your get_derived_state from props, which is like a static method that's really not used in practice. It's like very little use cases that we're not going to touch that. And then you have your render method, which is responsible for actually displaying whatever is being returned. So the goal, like I said before, is to render here and not after a component did mount, right? Because once we hit that component did mount lifecycle method, we've already went through our first render, and we've lost an opportunity to get the visualization in there right away. So again, the goal is to kind of do the heavy lifting in the constructor, and I'll show you what I mean by that. So this is our game plan. We're going to have JSON data in a hierarchical format. We're going to have a React app. We're going to create a React container component. So far, all this should be very familiar if you use React. The container component is where we're going to render our SVG, right? I don't know why that happened. So now, I put data cloning and standardization as optional because I want to drive home that you don't necessarily need to standardize your data if you are developing an in-house D3 component for your project or whatever, your enterprise application. You might not need to standardize the data as it comes in. So I'm going to kind of leave that out for last, and I'm going to jump right to using D3 for the layout generation part, which is kind of the meat and potatoes of this talk, right? And then we're also going to need functional components that render props. I want to show you, before I dive into the coding, I want to show you a D3 script that, just so you, in case you've never seen a D3 script, you kind of have a point of reference, and then you could just throw it out. So this is a zoomable circle path diagram by Mike Bostock, because he loves his own library. Now, this is like kind of a cool visualization. You could drill down into it. The data that's being shown here is like pretty useless. But I mean, going back to what I said earlier, the D3 module system, if you want to learn D3 modules, you're kind of at an impasse, right? Because like the documentation just has all these modules grouped together. And I think it would be like kind of useful to look at it like this. And kind of break up the separation of concerns within that library. In other words, like, something like this could be fetch because you're not really using it, and there's less D3 modules that complement that module. But then for something like, manipulating SVG, you might have all those modules grouped like that, kind of in the same category, subcategory module. I think something like that would be useful, but maybe I'll build that in the future. I don't know. Okay. So I want to kind of switch gears a little bit and get some coding done. I think that's fun. I have this starter project that I gotta switch my displays 1 sec. Let me just mirror these. Right. So what I'm gonna do here, I just did a create React app with TypeScript. So this is just a create React app that was auto-generated, but there's not a lot of like TypeScript in there by default. If we want to start creating this, so you can see right here, right? There's just a red circle. There's an SVG tag right here. Can you guys see this?
You can make the background white and be a lot easier.
So the SVG tag right here it just signifies where the canvas opens up, and as you can see, we're dropping a single circle.
Also zoom the text a little.
Sure. Is that better?
Yeah.
All right, cool. Now I did this just for illustrative purposes. This like going to be our actual visualization. So if we just get a little pack directory going, we could create a file called pack.tsx, right? And do okay. Yeah, so this right here, this import star as React, that's something that you have to do for TypeScript. That's not necessarily essential. Right. So we have a div here, right? Right now, this is just a hook. I kind of don't want that. Export default. So the data that I want to use for this is, now we're going to be doing a circle pack diagram. The data that I want to use for this is just a simple data set of world population, and then it breaks down into continents, and it has the individual continent population, right? So the way that would look in a circle pack is you would have a circle that represents the Earth, right? That's kind of the goal here, is to have kind of your parent root node circle is the Earth, that's all-encompassing of the entire population. So now the radius of that root node circle is going to be determined by whatever the population of the Earth is, right? And then inside of that, as you saw before from the other circle pack diagrams, each continent would be packed inside of that Earth circle, and then the diameter of that circle, the radius, would also be determined by the population of that continent. So the data that we're going to be working with is probably not real because Antarctica has way higher population than it should, but I think it'll work. Yeah, so I'm going to steal this guy. Alright, so now we have some test data. Now, I'm specifying iTest data right here, which is just an interface. I don't want to get too deep into that, but it's good to go over because this kind of ties into the concept of generics that I want to talk about. So we just interface this out, iTest data. I think I actually have this right here written out here. Yeah. So you can just copy that. Okay. So it's declared, but it's not in there, right? So now this interface is essentially specifying 3 properties on each node. Now this is one hierarchical JSON object right here, but it's better to think of each one of these objects as its own node, right? So the Earth is its own node separate from its children, right? I think it's important to make that distinction because even though it looks nested, it's once we actually get this into something that D3 can understand, it's going to be an array of nodes, right? Yeah, Antarctica, that's definitely wrong. There should be like 1,000. Let's make that more accurate. Okay, now, we're specifying place, we're specifying children, we're specifying population. So once we pass this data into the component that we're making, we need some sort of a way to translate these parameters into something that our component can understand. So that's done via something that's called accessor props, right? Anybody ever heard of accessor props? No? Cool. So we're going to dive into accessor props today. It's kind of necessary for this. The goal inside this SVG, because this app right here in this file, this is kind of our consumer. We're going to be consuming the pack diagram that we're going to be making, and pack is going to take some data, that data, put this in the wrong file. Good job, Nick. Alright, so now we can take this test data and just pass it straight in here. Right, but we don't have a pack yet. We can import it. Okay, so this is doing absolutely nothing. Let's get a render function in there so we can start to display something, and then we, for now, let's kind of go back to what we were doing before, where we just have a little circle tag here. Now the circle element takes a CX attribute, which is the center, the X value of the center of the circle. We could just say 10, doesn't really matter right now for the purpose of this. The circle also takes a CY, we can put in 10 for that. SVGs, the way they work is the coordinate system starts in the top left. So 10, 10 would be, from the origin is in top left. It would be 10 down. Each X pixel is down 1 from the origin. And then Y is over to the right. So 10, 10 would be, if here's the origin, 10, 10 would be here. Right? And then the R, which we're going to specify 50, whatever. And then the fill color, you just put as blue. Switch it out.
Quick question.
Yeah.
The circle element, how does it, do you need to import something from D3 and module from D3 for it to recognize what that is?
No, those are just, that's just a raw SVG element. So I can show you what I mean. If we type in SVN circle, sorry, SVG circle MDM, this is like my go-to docs, right? A circle is just an SVG element, basic shape, used to draw circles based on a center point and a radius. Right? Here
So
is
where does the D3 come in?
Good question. We'll get there. So right now this is blowing up because now, this is, what is this telling us? It's saying we're passing in a data attribute, but we never specified it. Maybe now's a good time to do that. So let's dive in here, and we'll get our, so in other words, this React component takes 2 parameters right here. These are type parameters. The first one is props, and the second one is state. A good kind of like rule of thumb, some people like to do this, some people don't. You could prefix the name of the interface with an I, and then you could just call this pack props, right? And then this could be I pack state. Obviously these aren't defined. So if we say interface I pack props, now here we can specify data, right? But what's the type of data? How do we type that out? We don't know that what the data is going to be because, I mean, look, React, why are we using React? So we can break things up into components so we can make things more modular, reusable. If we're developing this pack component, we want it to be reusable. So we don't want to specify a specific interface for the data right here. We want it to be generic. So we can just call it datum. Now, datum is, they're going to say, okay, well, you have to pass that into the interface. So if we pass that in right here, then all should be well, right?
Mm-hmm.
So if we pass that in right here, then all should be well. So if we pass that in right here, then all should be well, right? So if we pass that in right here, then all should be well, right? So if we pass that in right here, then all should be well, right? So if we pass that in right here, then all should be well, right? So if we pass that in right here, then all should be well, right? So if we pass that in right here, then all should be well, right? So if we pass that in right here, then all should be well, right? So if we pass that in right here, then all should be well, right? So if we pass that in right here, then all should be well, right? So if we pass that in right here, then all should be well, right? So if we pass that in right here, then all should be well, right? So if we pass that in right here, then all should be well, right? So if we pass that in right here, then all should be well, right? So if we pass that in right here, then all should be well, right? So if we pass that in right here, then all should be well, right? So if we pass that in right here, then all should be well, right? So if we pass that in right here, then all should be well, right? So if we pass that in right here, then all should be well so this is like, now, I want to cover this now and kind of just flatten this out, because this was something that was very, very, very confusing to me, and took me a while to kind of grok, but I grokked it. So when you're passing in a generic type to your interface, you have to, like, where are you getting that generic from? It's not going to be generic at runtime, right? You're passing that generic in here. You're literally, now we already specified like what the type of test data is, but the pack component doesn't know what the type of test data is. So we're passing in the actual data, but what's the type of that data? Well, it's iTest data. So if we pass that in right here, okay, now they're saying, okay, well, you didn't specify that data meets can be passed into this component. So I have to do that here. Now, once you start introducing generics, this really starts to get messy and very hard to keep track of, right? But that's kind of what's beautiful about TypeScript in a sense, because even though it's more verbose and we're writing more code, these linters are helping us out. Like, they're bending over backwards to help us out. It's letting us know exactly what we haven't defined yet, what we still need to define. So this is like a really good code style in my opinion, because you're able to kind of just start typing it out, and then like you hit an error like this, and it's pretty obvious like what the solution is. It tells you. I don't know if we'll need that for state actually. All right, so now here we go interface iPack state, which currently we don't have anything on state because they haven't defined anything yet. So we can leave that. Key children is not sorted alphabetically. Really, guys? So they're complaining because these are not sorted alphabetically. Cool. Well, let's see what we can do here. I'm being tested in my English.
But why is it compiled compilation zero? Why it is not like TS-Link or whatever?
I mean, yeah, I could. So this is just the create React app TypeScript version. So it's coming with like a lot of configurations that are like not really something I care about. We could go into. Let's see. I mean, yeah.
Can you do the TS-Link disable thing?
There we go. Disable rule. That was their quick fix. Want to make the interface empty, let's just go that. So we don't have state, so we don't have to code it yet. Can I get a circle? Yes, I can. All right, cool. So now you can see how like the center of the circle is kind of like up in the origin right now. It's lost in the sauce. So if we just add some zeros here, that should buff it out. And now it should be, yeah, there we go. All right, cool. So now our pack is just returning a single circle. That's not very useful. So what we're going to do now is take the data that we're getting and we're going to render it.
That circle is supposed to be the population of the entire world.
Yes. Okay. So we need a constructor. Our constructor takes two arguments here. It takes props and default props, and that's definitely not how you spell default props. Now, I didn't realize this until recently, but if you want default props in your React component, they don't actually, like the instance, the props that you have access to through the instance doesn't have access to the default props right away. So that's kind of what the constructor does. It's one of the things the constructor does is it kind of blends them. Okay, and now Dan Abramov says that we should put things on the state which have to do with what we're returning and what's being rendered. So before we keep going, I think it's important to talk about how kind of like the core of D3 SVG visualization is like the 101. The first thing you do is you specify height and width, right? Because if you don't have a height and width, then D3 doesn't know how to calculate the layout. So height and width kind of set the boundaries of the view box of the SVG canvas, and that's like, you know, the bread and butter props that you're gonna need. So we can say height is a number, and width is a number, right? That height and width is gonna end up on state. For now, I don't wanna, like, we can go back to this later. For now, I'm just going to put the props height and width onto the state. And you could be like, all right, well, you have height and width in your props. Why do you need it on state? You probably don't. I mean, for this visualization, we probably don't. It's probably overkill. But I think it's worth talking about why we want to put it on state. You know, in the real world, your visualization might be part of a web page that needs to be scalable. In other words, if somebody is on your web page, they're looking at the visualization, and they shrink the browser or they make it bigger, the visualization might need to grow with it. So the initial height and width that's being passed in might change. So that's why it might be useful if you're trying to build something that's scalable to put that on the state. This way you could manipulate it later, you could call set state, and that can trigger re-renders and kind of keep things in the flavor of React. Right?
Quick question.
Yeah.
This height and width, how does it relate to the, see in the circle you're putting in 100 at CYCX, so how does it relate to the overall depth?
So I just did this for kind of like just to confirm that, you know, I'm going in the right direction.
I'm just saying the coordinate system of, you're putting in the state, you're putting in height and width. I'm just trying to understand how that relates to the overall coordinate system that, you know, you said is basically the fourth quadrant, right?
Mm-hmm. So here in this consumer right here, we're dropping the SVG canvas in there. I'm going to take this code out. Right? We're just going to have a body, and we're going to drop the pack in there. So the way that we're going to do this is the pack, the component that we've been developing over here. This component is going to be responsible for rendering the SVG canvas. I'm not a huge proponent of God components in React. I don't think they're they're best practice at all. I'm going to shy away from calling this pack component a God component, but it's definitely the root component of this visualization. To go back to your question, how does the height and weight fit in here? One way that we could do this is we could specify like just a style on the div, and we could pass in something called div style, and we can set div style equal to an object with a height and a width, and here we can kind of use some string interpolation, and we could drop in the height from the state, right? So we could say const height width data locus.c. Alright, so now we have.
Where does this canvas really begin?
Where does the canvas be? Oh, it doesn't yet. Technically, it's really not there yet. But with the height and the width, we could drop in the height from the state here. If we specify pixels, then we'll get it in pixels. Now, I'm not saying this is the best way to do it. This is just a way to do it, just for the sake of this presentation.
In this coordinate, so what is the unit? Is it pixels or because it's vector? So what is units there?
Yeah, that is a good question. SVGs have their own pixel. It's not like an actual pixel, but that's I actually looked into that. That's a really it's a complicated answer. That's kind of beyond the scope of, like I said, I don't want to cover SVG vector mathematics in depth.
Technically, it couldn't even be pixels because it's scaling. It's scaling based on, so if you zoom it up, it will actually take up more pixels.
Right. Exactly. So I mean,
So it is a vector really.
it's useful to think of the SVG canvas. You know, each unit you could think of it as a pixel, but is it an actual pixel like a CSS pixel? No, it's not. It's a little bit different. I mean, for here it is, but it's a complicated answer. Just say this. Okay. So then here we can specify like background color. And we can just set this to, I don't know, wheat. Or black maybe. Sorted alphabetically. They loved it. Like, who created that tool? Like, it matters. Alright. There you go. So now we're passing in the div style. They're complaining because our interface doesn't have these properties typed out. So the data that's going to be on state, I'm going to keep this datum for now, but this is actually, you know, I think the best practice, and I'm going to say this again, like when your data comes in from props, you don't want to manipulate it directly. In my opinion, the best practice is to clone the data that you get from props. And once you've cloned the data from props, assign internal properties to it based on the accessor functions that are passed in. So it sounds like a lot, but what that actually means is, you know, if we look at this data, we have these fields that I switched these fields to be something else. This was originally name, and this was originally, I think, value, because those are like the default fields for like hierarchical JSON. But I changed it to place and populations. Now that kind of throws a wrench into this presentation, because now the only way for the consuming component to read from that data is to have knowledge of those fields. In other words, it has to be able to translate this place field into something that it can understand, right? So that's done in the function that I'm hopefully going to get to called assign internal properties, right? Now, why would you want to do that? Why would you want to assign internal properties? If we have a bunch of accessor functions that enable us to read those values, every time we want to get value, a specific field from that data, we'll have to go back to our accessor function and use the accessor function. The accessor function is going to accept, you know, an object of data, and it's going to pick out the parameter that is specified by the user. So, I mean, we're not actually able to render any of this data unless we have accessor props, right? So you can call these IPAC accessor props, right? Now on the accessor props, there's three accessor props that we need in order to make this work. The first one we'll go with is the key accessor. I've been calling these accessors for so long, just because I don't like saying accessor, but they're not accessors, they're accessors. So if you hear me say accessor, then just forgive me. So here we can specify that this is a function that takes a parameter d, and it returns a string. What are they going to say? D is not type. Right. Well, this is going to be data, whatever data is. So we have a key assessor. We're going to need a value assessor. And this is kind of the same thing, except the value assessor is going to return a number, not a string. And then we'll need a child assessor. So again, if we look at the data that we're passing in, the test data that I showed you, so this is going to be an array of data. Right? If we look at the test data here, we could kind of already start to see how these accessor functions tie in. In other words, this place property is your key. The population is your value. And children, self-explanatory, is children. So, in other words, we can pass these props in, essentially pass functions in as props that allow us to kind of sift through the data that we're looking at and take off the property that we actually need. So let's do that. Let's define some accessor functions here. So we're not going to need a child assessor. I'm going to show you how to kind of work the child assessor into the default props. But we're definitely going to need a key assessor and a value assessor. Obviously, I think it would be a better idea to kind of not write the accessor functions in line. So we can put those up here. We could say const key accessor equal function that takes some data and it returns what? The key. Well, what is the key? The key is the place. Right? Does that make sense? Let's just move this up here. And our value assessor, somebody tell me what the value assessor is going to map to. It's not place. Come on, somebody. There we go. Population. Right? So these assessors are essentially going to be passed in to our component here. All right? And now this visualization has a way to read the data that's being passed in. Because before we were passing in data, and it's like, okay, population, place, how am I supposed to know what that is? But now it's something that I can actually understand. So we have a key assessor, a value assessor. Now, we actually have to use those assessors, which is where I would like to assign internal properties. I wanna kind of save that part for last, because that's kind of like my opinion on what you should do, and that's less what's kind of important as a takeaway from this presentation. So I'm going to save the assigning of the internal properties for later. I think at this point, so, oh, no, we're not good at all. So they want, we are going to take the data that we get from state, and we need to somehow get it into a layout algorithm. So D3, like I said, it does a bunch of things. One of the most important things it does is it has these submodules called layouts. Depending on the type of data that you have, is gonna dictate the type of visualization that you want to go with. In other words, like showing this in a bar chart is possible. You know, we could have had a bar for each continent and sized the bar relative to its population. We could have done that. If we were to do that, we would want to use a different submodule than we're going to use now. So because we want to go with the circle pack diagram, we first have to run the circle pack data through a layout algorithm. The layout algorithm kind of normalizes the data set that's being passed in using the assessors, the key assessor, value assessor, child assessor. And what it essentially does is it enables us to call methods on hierarchy, and it enables D3 to call methods on hierarchy that are very useful for actually generating X and Y coordinates, right? Because we're talking about SVG, it's a vector. There's a grid, there's X, Y coordinates, kind of how you know, we were doing before with the circle. You had it 100, 100. So D3 is going to say, okay, well, what's the height, what's the width, and now based on that, what's the population of Earth? Okay, that population of Earth is this number here, right? So now we're gonna size the circle and to have a radius that scales to that population, right? But the actual X, Y coordinate of that root node of that circle is going to be determined by D3, the layout algorithm. So that's what I'm going to endeavor to get into right now. First, we're going to have to import some stuff from D3. And I'm pretty sure I already installed this module.
Shouldn't the world population be the total sum of all of the children?
Yes.
population?
Yeah,
So
the actual populations here are not accurate.
They're not accurate, but the total needs to be the total sum of whatever accurate or inaccurate children it has. So when you changed it to 1,000, Arctic into 1,000, you should probably also adjust the total population accordingly.
Yeah, I mean,
Basically, the total population needs to be the total sum of all the children. Whatever it is, and whether it's accurate or inaccurate, it needs to probably be a total sum.
let's test that. Actually, let's see if D3 is smart enough to, you know, render this, you know, with bad data essentially. I mean, we could always switch it back if it gives us a problem, but that's a good point. Yeah. Okay, so at this point we have our constructor, we have our render, but we're not rendering it. So in order to render, we're going to want to take nodes off of C and render those nodes in here. Right? So we'll need some function called like render nodes, and then we'll pass in the nodes. So render nodes, again, this isn't D3 yet. Hold your horses. Render nodes could be equal to a function that takes a bunch of nodes, and I think we could even do this implicitly. We could just say nodes.map, and then for each node, we could literally do what we were doing before with the circle, right? Except the circle now, this CX is going to be equal to whatever the node.x is. And CY, likewise, whatever the node.y is. I'm leaving this all in this component for now. Eventually we could break this out and make it more modular. This is just to kind of move us along. And then this would be node R. Alright, but we don't have any nodes yet. So we have to start mixing in some D3 here. No? Okay. Heating up here. created this repo to kind of simulate like an actual React application that's pulling in a module from npm, because I actually did this as part of my open source project. So here you just have like a dev server, we have a React D3 circle pack, and the dev server is symlinked, or rather the React D3 circle pack is symlinked to the dev server, so that any code changes in React circle pack will update the dev server, and that will trigger a rerun. So we got some hot module reloading there. So this watch script is just compiling these with TypeScript, and it's generating an ESM module. And then in our dev server, we can just start that up and see if this doesn't blow up. Alright, so I'm going to get rid of this guy here, and this guy here. And then we can move this one into the So this is mostly done. I don't feel like dealing with like syntax errors, and I feel like this is probably better to show you. So here you can see we're passing in test data, and we're also specifying a key accessor, but we're not specifying a value accessor. So if we do that. There we go. This is kind of like the end result. Now, let me kind of go back, because I kind of glossed over the actual crux of this presentation by switching over. Let's take a look at this, right? So now, a lot of this, again, this is like, it's my opinion. Like, I'm not necessarily saying, hey, this is how you do this. This is my opinion. Inside of the constructor, what I'm doing first and foremost is I'm taking the data that I'm getting from props and I'm decloning it, right? Because I mean, immutability, like based on that principle, if we're gonna make any sort of changes to our data, like for example, let's say this was more than just a static visualization. Let's say when you clicked on one of these continents, right, that it maybe displayed a tooltip, or it did something. Or maybe when you click on it, the color changes, or something like that. Now, for all those things, okay, maybe for the color change, you can do it with CSS, but maybe there's some part of your application that is going to want to mutate that data. So if you're cloning it, so if you're cloning the data and you're putting it on state, then you could be confident that like any changes to that data is not going to mutate your props. Now here, this inside internal properties, this is what I said was kind of like, not necessarily a mandatory method, but I think this is very useful for standardizing your data. Now, the way that I went about this was I wanted to avoid collisions. So all these properties that you see right here, these static properties on the class, they're pointing to symbols. And I went with symbols because they're immutable. You could also use symbols as keys on an object. So pretty much with this paradigm, you can be almost 99.99999% sure that by appending properties to the data that's being passed in, you're not going to overwrite anything that's already there that you shouldn't be touching. That's why this is so ugly and verbose, right? This is literally the name of the component itself, and then it's accessing static properties, which they look like just regular strings or whatever, but these are actually defined up here. These are pointing at symbols with the same name. So it's appending those values onto the actual node via the accessor, right? So we're passing the node, whatever node that we're on currently, into the accessor function. The accessor function is looking at that node and it's saying, well, I'm the value accessor, and I map to population. So when this node is passed in, I'm going to take the population from the node. I'm going to create this property here that's essentially a symbol called value, and I'm going to point that symbol value at the population. So now, every single time that we want to access the value, we don't have to worry about using an accessor function. We can just use this. And that's my personal style. That I didn't come up with this, I didn't invent this. I borrowed this from somebody, I don't remember. But I personally like this. Actually, BK Around, that's where I got this from. In his constructor, he assigns internal properties, kind of like how we're doing here. This is like really unconventional. I like for all the years that I've been writing React, which is not that long, but I haven't seen like a lot of work done in the constructor. So this is kind of like, not your average React component, but the goal here, like I said in the beginning, is to render the visualization on the initial render. So with this architecture, you're able to do that because all the heavy lifting is being done in the constructor. There's the constructor, and then there's two other methods that are being called from inside the constructor. Right? Now I called this mad props because I'm from Staten Island. Really? But mad props is essentially, now again, this is default props, and then props, this is essentially what's going on behind the scenes. This isn't wholly necessary, but I just thought this was useful because now I could just access mad props off of everything, and I could just throw mad props in to get hierarchy circular nodes, right? So this first one, like I said already, this appends these internal properties onto the node, right? Now, this piece right here is your recursion, because if you remember, what we passed in initially was essentially a JSON object that is individual nodes that aren't really kind of obviously individual, because unless you recurse over them, like how else are you gonna like append those properties? So that's why I just did like a simple for each here, passed in the assigned internal properties, and now it's essentially so this line actually is important. So without this child accessor, we won't really know if there's children. So we first append this property onto the node, and then we use it literally right away, like right after we append it. We're saying, all right, well, does that node have any children? If this is truthy, then it's going to kick off the recursion process, and likewise, that's going to trickle down, from the top down. So now we have all our internal properties assigned, and you can actually see that. Let's see if we go. Actually, let's drop it right in here. Right, if we put a debugger here, I'll show you. Now, this is like where you're going to say, Nick, this is stupid. Why are you duplicating all these properties? And you're not wrong. I don't think it's necessarily the best way. There might be a better way to do this, but if you notice here, if we check out what our data is, we have place Africa. Can you guys see this? We have place Africa, right? But then we also have a symbol that's the key that's also pointing Africa. And then we also have a label that's pointing Africa. So there's a lot of duplication of properties here, which is like, I'd say this is the one drawback to this method. You could actually strip out all of these right here, the place and the population, because we already kind of standardized that in a format that our module can actually process. But the reason why I think it's useful to leave this in here is because these internal properties, these symbols right here, that's for the component. That's for the visualization so that it can read the data. Now, if you have some sort of a callback function, like if you click on a node, right? And now you want to feed that data from that node back to the user who's using the application, right? That person might be expecting place and population. So if you return the data back to the end user via a callback, and you don't have place and population on there, you know, the people who are using this might not know about these internal properties, and they might not know how to access them either. So again, this is a way to kind of account for edge cases, but this is maybe not the best practice. I'm not sure. All right, let's get out of this. All right. So if we take out this debugger, now this is where D3 comes in. So if you fell asleep, wake up. Get hierarchy circular nodes, right? I called it this because I'm trying to stick to the convention from D3 hierarchy, right? If you install D3 hierarchy, then they ask you to install the types for D3 hierarchy, which is great because then you have access to all these interfaces. So this is a layout function hierarchy. This is, now remember, this is like what I said, is kind of like your intermediary stage before you pass the data down to the pack layout and you actually create a circle pack layout. You pass it through hierarchy first. So essentially, it's actually like a tree. The data goes into hierarchy, and then you have options. You can go with a pack layout, you could go with a tree layout, you could go with a tree map. You could go with a variety of different visualizations from that point. But I think the key takeaway is the fact that it has to go through the hierarchy first. And you see that inside of this function here, get hierarchy circular nodes, right? So this is taking in the data, which if you remember is coming from props. Now this is the data after the internal properties have already been assigned. So if we wanted to call this function in the future, we could literally pull the data from state because that's literally what's right here. We could pull that data from state. Now this is a safe function right here. This isn't mutating anything. What this function is doing is it's taking the data that we have and it's running it through both the layout functions. Okay? The first layout function is right here, hierarchy. The second layout function is pack. Now the reason why I have a ternary here is because depending on whether or not your data has a value, in other words, if we were to use a hierarchical JSON data set that didn't have values, and I mean, like we kind of saw that with the documentation that I showed you before where it listed out all the D3 modules, and it kind of organized them into subcategories and categories. There was no values, there was no weight to each one of those submodules. So if we were passing in a data set like that that didn't have any values, then we wouldn't want to use this function right here, this sum function, because this sum function is calculating the radius of each circle based on the value that's assigned to that node. But if we don't have a value, then we don't want to call that sum function, the whole program blows up. So right here, I just added a branch that just says like, okay, well, if you pass in this prop called no node values, which is a Boolean, then you have the opportunity to kind of allow the layout to pivot and generate a end result hierarchy data set, a hierarchical data set that that doesn't account for the value. So here's the first step is running it through the hierarchy, and then here's the second step, which is running it through the actual pack layout. So I'll drop some debuggers in here and kind of show you like what this looks like through each stage, which I think might be helpful. All right. So this is assign internal properties. So hierarchical circular nodes, right? Now, if we look at, so the first iteration of this is inside of this root variable right here. If we check this out, actually first let's look at the data. So now the data that's being passed in, this is not the data from props, this is our internal data that we've assigned internal properties to, right? So this has that, you know, those field duplications, like I said, those value duplications. If we check out the root, Now, with this one, this is like really, this could be a huge waste of space, right? Because like, what if each one of these children has children? Now you're duplicating that array, so this isn't super performant. Removing this field is probably, I mean, leaving like these primitives on there is probably fine, but as a best practice, like it might be a good idea to get rid of this entirely. The end user is going to care less about maybe what the children are, but I mean, this is just giving the user the most power possible. So after we run it through the hierarchy function, right? If you notice here, there's a lot of the same properties on the surface, but it's completely different, right? This is the data set. This is a JSON blob essentially, and you know it has properties that open up into more and more and more. Okay, great, but you know what is this? Well, it's the same thing. It has properties that open up into more and more and more, but it takes all of the properties and it essentially puts them into an object called data, right? And now this children property right here is something that D3 added. This is their children property. We also have a depth now. We have a height. This is the root node, so the parent is null, right? The value is whatever the value assessor said it is, which is population. So this is the population of it. Now, what did we say? So the population of Earth was 573. Okay. I mean, this value doesn't match up. So to answer your question, maybe D3 was able to account for that difference, and it was just like, wait, your population's wrong.
Well, you can see the circles floating around in a much larger circle, so when you render it.
So that's our root. Now with root, when we pass that root into circle nodes right here, right? That's happening right here. So when this root is being passed in, like D3 has this like, it's a little unorthodox, like it's like old school JavaScript in a way, where it's like an iffy style. You're like invoking the pack function and you're specifying the type with the generic here. And you're also specifying the size, it needs that to compute. Now like notice like the hierarchy layout, that didn't need a size with a height and width, right? But the pack layout does need a height and width, because the pack layout, this function right here, again, this is the piece of D3 code that you need if you want to generate the actual X and Y coordinates for each node. So after we run the root through the pack layout, we hit our next debugger, right? And now we can check out these circular nodes. Now notice, it's still like a JSON with properties, but now we have Y's and X's and we have a radius. This is the D3 part here, right? These numbers, the generation of these numbers. Now, until we call this method descendants, it's going to be in a JSON form like this, right? But if we call descendants, circular nodes descendants, right? This gives us an array of nodes. All right, cool. So now that root node is going to be the parent, and then each one of these nodes after it is going to be one of the contents, right? Now that it's weird because like when you call descendants, you'd expect it to return only the descendants of the root node, not the root node itself. But it's an intelligent API. It knows what you really want, so it gives you the root node too, which is awesome. Now, if you notice, like in the code base, like we're literally returning the descendants. We don't care about the circle nodes by themselves. That's less useful to us for the sake of the visualization. We want it in an array-like form so that we can iterate over it like an array. So now this right here, remember, this is all happening in the constructor, right? The get hierarchy circular nodes, that method call is happening in the constructor. The return value of that we already saw is an array of nodes. Those nodes are now on state in the first render. Once the constructor's done, we have all the nodes we need, all the XY coordinates we need, the radius, all that. We have all of that on state available to us in our initial render. No component in now. Okay? Now here, inside the actual return, we're just returning render circle nodes. This is where we're kind of abstracting out the the rendering to a child component here. So that's where you have your circle. Now I specified get fill color. One of the things I've been wrestling with while developing this is how I want to enable users to specify colors. Kind of like the standard way to do it is to use color scale and then essentially assign colors to each depth within Circle Pack. But another way to do it is in the actual circle itself. So this is the way I have it right now. I'll probably end up changing it because this is kind of basic. But you can see here, now inside of this circle component, we have a G element. A G element is you could think of a G element as a div. The same way you have divs in HTML, you have Gs in SVG. What do you think G stands for? Nobody? Group? No? So you have a group. Why do you have a group? Because you have a circle and you have a text. Right? And you can see that in the visualization. Each one of these circles is being rendered with its text. Now you could argue that maybe you don't want to do that. Maybe you want your circles to be one thing, you want your text to be something else, right? You would be able to, I think the reason why I did it this way was because the way that I'm positioning the text is relative to the circle. So I wanted to kind of couple them together so that I could assign the same X and Y values that I'm using for the node onto the text. If I didn't do it this way, then I would have to come up with a different way to get those X and Y values. And I'd have to somehow figure out what the label is and map it, while rendering in a different component. So I think this is okay for now. But,
can you see how much blue you have? Like a sea of blue that isn't really representative of anything. And
yeah,
that shows you-
look, the circle pack diagram is not the sexiest diagram. And the problem with the circle pack is there's an immense amount of wasted space. If you want an efficient visualization for this type of visualization, you could go to tree map, which uses a rectangular space. It's basically a circle pack, but it's rectangles.
What I'm saying is that because you didn't change your numbers when you took off the target because population, that's why you have so much more.
Yeah, but this data set I never actually touched the number. Antarctica is the where is it? It's in the demo. Yeah, Antarctica is still 51. So
Yeah, look, it's like the largest circle.
yeah. Cool. Anybody have any questions?
The thing that you said about the group, I think you're doing that because you need to do the React fragment in that case. You say also that it's related to the coordinates. Can you explain why? If you change that group to React fragment, it would be the same thing, right?
So React fragments have to do with the React component itself. You want a group element here because there's a lot going on that you're not seeing. Let me explain. When you have these functions here that run, right, hierarchy and circle nodes. If you think about it, you're passing it through hierarchy not because we care about it going through hierarchy, but D3 needs it in hierarchy, right? So to answer your question, there's things that are being called behind the scenes by D3 that aren't even visible to us right here, unless you were to dive into the source code and you say, oh, well, there's a method that hierarchy allows you to call on it that pack layout is calling. That's actually helping it figure out how to determine those X and Y values.
Yeah, so
So with a group element, there's certain things that group element gives you. We could look this up, right?
my question is like, since you haven't used in view box, the thing that you say is related to coordinates doesn't apply here because you haven't used view box.
Okay, so for the purpose of this visualization, maybe we could have used a fragment. I don't know. Let's try. Let's just see how it looks. But I want to explain to you why that might not be a good idea. Yeah, so you could. But now, what happens if you want to assign a ref to this? Right?
So
Can you assign refs to fragments?
none in that case.
I don't know. That's a good question. Now, this visualization is static. So I used the absolute minimal amount of D3 I possibly could to generate this. But I would argue that this visualization is not cool for all intents and purposes because it's not cleanable, right? I can't click on this and do anything with it. It's static. I mean, it would be really cool if I could click on, I don't know, maybe Antarctica is a bad idea, but like Asia, and then it would zoom into Asia and show me all the individual countries and their populations. Like that would be a better data visualization than this. So when you do things like tween, we totally don't have time to go over that right now. That's like a whole 45-minute thing. But like the way that you would do that is you would have a ref, right? Let's say that you still have G elements. You would assign a ref to that group element, like this dot gref, right? And there's a submodule by D3 called D3 selection, right? So you could actually import this. I didn't install this selection module inside of this particular project, but not that. But you would essentially import it like that, right? Select kind of ties into what I said before about the exit, update, enter pattern. If we look at kind of like another D3 script, yeah, so I'm just going to make this bigger for a second. If you notice, the first thing that this dude does, or whoever made this, is call select, right? What is it? What are they selecting? They're selecting the SVG on the DOM, and that they're literally passing in the height and width. So this is kind of like a traditional D3 script, where you select a DOM element, you assign attributes and styles to it, you assign an on-click handler. I mean, we could literally, like this whole block of code right here, we could easily break out into React, easily, because you're selecting an element to assign attributes to it. In React, we could just drop the element into the return, you know, and pass some properties onto it. If you want an on-click handler, pass that onto it. Like React has a way of doing this that's very efficient and React-like and scalable. People are comfortable with that. A script like this, I would argue that it's less scalable and it's harder to maintain. And the people who usually write these scripts, they write a script like this that's meant for a very specific data structure and a data set rather. Like for example, the New York Times website, they do D3 visualizations all the time. They'll write a raw script like this. They're probably not breaking it out into a React component because they don't need to. They're not going to need to. They're not going to need to reuse the same data visualization for a completely different data set. They're building data visualizations that are unique to a specific data set. That's not what we did here at all. We made a data visualization that's like scalable and kind of like flexible and can be used in a variety of ways. So there's one part here. So here there's select all, right? Now here's where the data is actually being passed in. You can see group.descendants. We kind of saw that pattern already. They're passing in the descendants, which is an array of those nodes generated from the layout, and then they're joining them. So like, there's some things going on here that this block right here, I would argue, is a little harder to read through and reason through at like a first glance, especially if you don't know D3, because now there's kind of more things going on. There's branches here in these callback functions. Like there's like this is the part where you're now, sorry, like if you were to take this script and just drop it into a React component and say, yeah, I have this React component, but I'm going to allow all the DOM manipulation that this component does to be in the hands of D3, and there's people who do that too. Like if you look at like Fabio Biondi, he came up with something like that. Yeah. Like if now this is a React component, right? He did this in React. This is React D3 pack. But if you look at his source code for this, he's mixing a lot of kind of, where is it? Yeah. So in D3, this is completely not what I just showed you. He's using a lot of D3 right here to manipulate the DOM, which is like is not really a React way to do it. I mean, you could easily do this and ship an npm package. You could do that, but for me, in my perspective, I think it's better to make it more React-like. At least that's how I feel comfortable.
He's taking the entire D3 library.
Right. Exactly, which is heavy and is probably not great. Exactly. You see that a lot, actually, with a lot of like D3 modules that are available on npm. Like there's people that put together like a D3 sunburst that you could drop into a React application. A lot of them tend to do that. They'll just import the entire D3 library because, and I don't want to get into this too much, but if you use rollup, you could very easily tree shake off all the modules that you don't use. So importing something in a modular way was the rage in D3 version 4, but you don't necessarily have to do that anymore. And like in the past year, tree shaking was like really kind of taking root. No pun intended. So yeah, I mean we covered a lot here. I feel like I'm like way over 45 minutes. But yeah, any more questions, or feel like you guys came away with something? Cool. Well, thanks for listening. Thanks for not following.